Are electric vehicles as green as they seem? Let's start by digging into the environmental impact of their production. Electric vehicles, or EVs, are often hailed as the saviors of our planet, with zero tailpipe emissions and the promise of a clean green future. But beneath this shiny eco-friendly facade, there's a darker side that's often overlooked: the environmental impact of producing these vehicles, particularly their lithium-ion batteries. A key component in the power of these vehicles, these batteries are packed with lithium, cobalt, and nickel. However, the extraction of these elements is a process that often leaves significant ecological scars. Picture vast open-pit mines eating into the landscape, disrupting habitats and polluting water sources with toxic chemicals used in the extraction process. This image is a far cry from the clean green ideal that we often associate with electric vehicles. And then there's the issue of greenhouse gas emissions. Yes, you heard that right. The production of electric vehicles, or more specifically their batteries, contributes to the very problem they're supposed to help solve. The mining, refining, and transportation of lithium, cobalt, and nickel all result in substantial carbon emissions. So, while electric vehicles may not emit carbon dioxide while they're on the road, their production process tells a different story. It's a story of significant environmental impact, of water pollution, habitat destruction, and greenhouse gas emissions. It's a story that challenges the perception of electric vehicles as a purely green solution. But this isn't to say that electric vehicles are the villains of the story. Far from it. The potential of EVs to reduce our dependence on fossil fuels and curb tailpipe emissions is undeniable. But it's also important to consider the full picture, to understand that, like all things, electric vehicles come with their own set of environmental costs. So, the production of these eco-friendly machines isn't as eco-friendly as it appears. As we move forward, it's crucial that we address these issues, looking for ways to minimize the environmental impact of battery production and make electric vehicles a truly sustainable solution for the future. Moving beyond the environmental, let's delve into the ethical concerns surrounding material sourcing for EVs. We cannot ignore the fact that the production of electric vehicles is often linked to human rights violations. Consider the Democratic Republic of Congo, a key global supplier of cobalt, an essential component for EV batteries. Mining in this region is a fraught endeavor, tainted by unsafe working conditions and, most disturbingly, the widespread use of child labor. Children, some as young as 7 years old, are often found working in these mines, risking their health and their lives. The ethical implications are stark, raising questions about the true cost of our transition to green energy. As we embrace electric vehicles, we must also grapple with these hard truths. The burden of responsibility lies not only with manufacturers, but with us, the consumers. Clearly, the sustainability narrative of electric vehicles is more complicated than it first appears. Next up, let's uncover the truth about the carbon footprint of EVs. While these vehicles certainly emit no tailpipe emissions, their overall carbon footprint is a different story altogether. This isn't just about the car itself, but also where its energy comes from. Yes, if the electricity used to charge these vehicles is generated from renewable sources like wind or solar, their carbon footprint is significantly reduced. But here's the rub. In regions where power is primarily produced from coal or other fossil fuels, the environmental benefits of EVs take a substantial hit. The dirty secret is, where your electricity comes from can determine whether your EV is a hero or a villain in the fight against climate change. In other words, an electric vehicle's green credentials are only as good as the grid that charges it. So, it seems the carbon footprint of an EV isn't as small as we'd like to think. Now, let's address a major concern: battery life and disposal. There's no denying that the lifespan of electric vehicle batteries is a concern. Like any rechargeable battery, they lose capacity over time. But the real issue isn't just about how long they last, it's also what happens when they're no longer useful. These batteries contain toxic and hazardous materials, so simply tossing them in a landfill isn't an option. This is where effective recycling methods come into play. They're crucial in mitigating environmental risks. Unfortunately, the current recycling rates for electric vehicle batteries are relatively low. This means we have a growing pile of spent batteries and no efficient way to handle them. And as more electric vehicles hit the roads, this issue only magnifies. The problem of battery life and disposal is a significant hurdle on the path to sustainable electric vehicles. Let's now turn our attention to a common concern for potential EV owners: range anxiety and charging infrastructure. The fear of running out of charge before reaching a charging station is a real issue. This concern, known as range anxiety, is exacerbated by the limited range of many electric vehicles. Despite the continuous advancements in battery technology, most electric vehicles still can't match the distance a conventional car can cover on a full tank of gas. Moreover, charging infrastructure is far from widespread, especially in rural areas. While cities are gradually adding more charging points, rural and underserved areas often lack sufficient infrastructure, making long-distance travel in an electric vehicle a challenge. It's essential that we ramp up the development of charging networks to match the growing popularity of electric vehicles. Clearly, for long-distance travel, EVs still have some catching up to do. Next, let's talk about money. The economic considerations of owning an EV. The initial cost of purchasing an electric vehicle is typically higher than that of a conventional car. For many, this higher price tag can be a deterrent, making electric vehicles less accessible to a broad segment of the population. This is a significant hurdle that must be overcome if we want to see widespread adoption of electric vehicles. Sure, running costs for EVs are lower, considering factors like fuel savings and reduced maintenance costs. However, these benefits often only start to outweigh the initial investment after several years of ownership, which isn't always feasible or attractive for potential buyers. As a result, the high upfront cost remains a barrier, overshadowing the potential long-term savings. So, despite lower running costs, the high upfront price of EVs can deter many potential buyers. Let's consider another hidden drawback: the impact on electricity grids. As electric vehicles gain traction, we're seeing a surge in demand for power. This isn't just about charging your car at home, it's about every EV on the road and every charging station drawing power from the same grid. Now, imagine if the uptake of EVs accelerates rapidly. We could be looking at a serious strain on our existing electrical infrastructure. This means the potential for blackouts, power shortages, and other disruptions. And it's not just about quantity. The timing of power demand for EV charging can also be a challenge, particularly during peak hours. We're talking about a grid that was designed for a world before electric vehicles, so while EVs are a step forward in many ways, they also present new challenges. And one of those challenges is ensuring our grids can handle the load. As EV popularity grows, our electricity grids could be in for a shock. Now, let's discuss how EVs perform under extreme weather conditions. Electric vehicles, like all machines, are subject to the whims of Mother Nature. And she can be rather unforgiving, especially when it comes to temperature extremes. Picture this. It's a bitter cold winter day. You hop into your electric vehicle expecting to travel your usual distance, but you find that your battery's efficiency and range have taken a significant hit. That's because cold temperatures can cause a considerable dip in battery performance, limiting your travel range. Now, imagine a sweltering summer day. The heat is relentless, and your EV's battery is feeling the strain. High temperatures can accelerate battery degradation, shortening the overall lifespan of your battery. These performance issues in extreme weather conditions can pose a unique set of challenges to electric vehicle users, especially those living in regions with significant temperature fluctuations. Extreme weather conditions pose a significant challenge to EV performance. Finally, let's discuss a lesser-known concern: the dependence on rare earth elements. These elements are critical to the construction of electric vehicles, particularly for their electric motors and batteries. The catch? These materials are not so common. The supply is limited and predominantly controlled by a handful of countries, creating a form of dependency that could have significant geopolitical and economic implications. Imagine a scenario where one of these countries decides to limit or halt their export of these crucial elements. The ripple effect on the electric vehicle industry could be substantial, leading to increased costs or even production halts. It's a delicate balance, and one that underscores the need for diversification of supply, increased recycling, and the development of alternative technologies. The dependency on rare earth elements is yet another hurdle on the path to sustainable electric vehicles. It's a complex issue that needs addressing as we continue to drive towards a cleaner, greener future. Having discussed the concerns surrounding the production and use of electric vehicles, it's crucial to remember the importance of innovation and alternatives. The electric vehicle industry is still relatively new, and like any emerging industry, it faces many challenges. However, these challenges also present opportunities for innovation and development. Research is ongoing into alternative materials and technologies that could reduce dependency on rare earth elements. Efforts are also being made to design more efficient batteries, enhance recycling processes, and improve the sustainability of vehicle production. Innovative solutions are being developed for infrastructure challenges too, such as smart charging systems and better energy storage. The journey towards sustainable electric mobility is a marathon, not a sprint. It's a path filled with obstacles, but also opportunities. As we continue to innovate and explore alternatives, we make progress towards a cleaner, greener future. Remember, the future of electric vehicles depends not only on the manufacturers and policymakers, but also on us, the consumers. Our choices can drive demand for more sustainable and ethical products and push for innovations that address the challenges we've discussed today. So what do you think? Are electric vehicles the future? What changes would you like to see in the industry? We would love to hear your thoughts. Thank you for watching. Don't forget to leave your comments and subscribe to our channel for more insightful videos.